Alright, so we're going to move from the sine and cosine graphs to the secant, cosecant, tangent, and cotangent graphs. Let's start with cosecant, which we know is the reciprocal of sine. So what I've got in front of you is I've got a graph of sine, and we've taken a look at this a couple of different times. Starts at 0, goes up to 1, down to 0, down to -1, and back up. And I've got two periods of that going from -2 pi to +2 pi. Now, if I want to graph the reciprocal of that, then I have to take every point on this graph and take 1 over that. So let's start with the easy ones. 1 over 1 is 1. 1 over -1 is -1. I do that everywhere. Now, at these points, we have 1 over 0, which is undefined. So what I actually have is asymptotes here. Everywhere I have a 0, I have an asymptote. Next, since I can't really connect the dots, I'm going to need some more points. So here I have a reciprocal of a half, which is 2, somewhere up here. Likewise, on the other side, I get the same thing. So if I connect all the dots, my blue graph is a graph of the cosecant. Do the same thing on the other side. Here's -1/2. -2 is the reciprocal. Likewise. And I rarely ever memorize what cosecant looks like. I just know it's the reciprocal of sine, and I take 1 over all the sine values to get my cosecant. So cosecant's basically just the blue graph. If I want the domain of that, well, this isn't defined for all values of x. In fact, everywhere there's an asymptote, it's undefined. And it's undefined at every pi value. So what I can say is I can say not equal to all multiples of pi. So I can say pi n, where n's an integer. Then if I want the range, I know the range is only where the blue graph is, so it's not where the black graph is. So the range goes from -infinity to -1, and from 1 to infinity. Let's move on to the next graph. Secant's the reciprocal of cosine. We're going to use the same idea we did before. Take all the reciprocals of 1 and -1 first. Here, here, and here. Find all the zeros. Have undefined values as their reciprocals. And then everywhere I see a half, just right around here, I get a reciprocal of 2. So you'll notice because secant and secant look very similar, however, their asymptotes are going to be in different places. And if we want the domain of this, you'll notice again, -pi/2 is a distance of pi between them. So we still have a distance of pi between our intervals, but we're starting at different spots. So in this case, let's say I start at pi/2, and we know the domain's not equal to that, and then we go every pi past that, so plus pi n is going to be my domain. Range, once again, goes from -infinity to -1, and from 1 to infinity. Now tangent's going to be a little bit different. So we're going, because we've never graphed that before, so we have nothing to go off of where we had sine and cosine to use for secant and cosecant. Tangent's a whole different ball of wax. So let's do this. Let's start at 0 degrees on my unit circle. and tangent's going to be my y over my x value. So at 0 degrees, or radians for that matter, I have a value of the y of 0 over 1. That's a 0 value. Typically we've gone up to pi over 2 next, so let's do that now. And in this case we have the y value of 1 over 0, which is undefined. When I go back to pi, I get another value of 0. Go to pi over 2, or 3 pi over 2, sorry. Get an undefined value. Then I go back to 2 pi, and there I am again at 0. Now I can't connect the dots here, so I'm going to need another point. I'm going to use this point right here, because I know here I have root 2 over 2 and root 2 over 2. In fact, all pi over 4 points are going to have the same x and y values. So when I take the y over the x, I get a value of 1, which let's say is somewhere around here. It's going to approach the asymptote. If I move into the second quadrant and look over here, I have a negative and a positive, which would get me a negative 1. So this graph is going to look like this on this side. Move over to here, I have 2 negatives, which is a positive. And then move over to here, and I have positive and a negative, which is a negative. So there's a typical graph of tangent. Now you'll notice in this case, start at 0, go up, cross over the asymptote, go up again, and this graph actually repeats right here. So this green portion from here to here marks a full cycle, and thus gives us the period. For tangent, the period is equal to pi, not 2 pi like in sine and cosine. Right? And it turns out if I want to find my k value, a period is equal to pi over k instead of 2 pi over k. This is for tangent and tangent alone. The domain of this, anywhere I have an asymptote, is not good, so that's not equal to pi over 2, and notice 3 pi over 2 is full pi away. Pi n multiples away from that. The range goes up forever and down forever, so this is all reals. If we look at cotangent, which is the reciprocal of tangent, unfortunately, if I look at my other graph, finding the reciprocal of an undefined value, we don't know what that's going to be. So we're going to have to generate cotangent from our unit circle again. We know cotangent is the same as x over y. So again, I'm going to start at 0. And if I take my x value over my y value, I find out that's undefined. If I go to pi over 2, I take my x over my y value, I get 0. Go to pi, x over the y value is undefined. 3 pi over 2 gets me a 0 value, and 2 pi puts me back in undefined. Again, to find my x over y values intermediary between 0 and pi over 2, I'm going to take a look at all my pi over 4 multiples. And I know that at pi over 4 I get a value of 1, which means this graph has to look something like this. At 3 pi over 4 I get negative 1. At 5 pi over 4 I get positive 1. And at 7 pi over 4 I get negative 1. So here's a graph of my cotangent. You'll notice cotangent always decreases where tangent always increased. So again, taking a look at a period for this, where does this guy start repeating? Well, it starts repeating after pi. So the period, once again, for cotangent is equal to pi. The domain is basically 0, well, I don't have to say 0, but I can say 0 plus pi n, where n's an integer, and the range is all reals once again. So now if we take a look at some general formulas, we've got a general formula for the tangent and cotangent, which is really the same as the formula for sine, cosine, cosecant, cotangent. A is going to act like an amplitude. It's just going to stretch the graph since the range is all real numbers. It's just going to make it go higher faster. But the thing we have to note here is that the period is now going to be calculated by pi over k or 180 over k, depending on what you're using, radians or degrees. So we'll keep that in mind as we go through the problem. So now we're going to take and actually graph some functions with period changes and amplitude changes. In this case, we have the cosecant of 2 pi. If I want the period of this, period of cosecant is the same as period of sine. So the period is equal to 2 pi over k, which in this case is equal to 2. So pi is my period, which means my intervals are pi over 4. If I want to go ahead and graph that, I'll just graph a period, 0, pi over 4, pi over 2, 3 pi over 4, and pi. So the whole cosecant graph should happen here. Now here's the deal. I'm going to take and graph sine first. And I know a normal sine graph would go from 1 to negative 1. And a normal sine graph looks something like this. Notice this is not the graph of cosecant, it's just the graph of sine. Now, what I want to graph is I want to graph negative cosecant. So first of all, what I'm going to have to do is take the reciprocal of all of these. So in this case, reciprocal of 0, there's an undefined term in each case. The reciprocal of 1 would be 1, but I'm multiplying that by negative 3. So here's 2, 3, and I'm going to put that value down here. The reciprocal of negative 1 is negative 1, but I'm multiplying that by a negative 3. So that puts me up at 3. Now, in this case, there is a half somewhere in here and a half somewhere in here. I take the reciprocal of that, and that's 2, but then I'm multiplying that by a negative 3, so that's actually negative 6. So my graph is going to look something like this blue graph here. And you'll notice after this, it would repeat itself and go back down over on this side. Let's move on to the next problem. So now we'll graph a secant, and period, once again, is equal to 2 pi over k, which is 4. So pi over 2 is my period. My intervals are pi over 2 divided by 4, so that's like multiplying by a fourth, or pi over 8. So once again, here's 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. I'm going to graph cosine to begin with. So this will be 1, negative 1. Here's cosine. General graph of that. But you'll notice I have to take and find the reciprocal of this guy. So everywhere I see zeros, I get an undefined term for the reciprocal. Everywhere I see a 1, I know its reciprocal is positive 1, but I'm multiplying by negative 2. So at 0 degrees, I have a value of negative 2. I'm negative 1 here, which goes to positive 2, positive 1 here, which goes to negative 2. Once again, I'm taking the reciprocal of these halves here and multiplying those by a negative 2, which puts me somewhere down here and up here and then again down here. And that's one period of that secant graph. Now we're going to take and find tangent. This can be rewritten, and I would rewrite it, as a tangent of 1/2 theta. So in this case, my period is equal to pi over k. And k in this case is 1/2. So that's really multiplying by the reciprocal 2 pi. So what I have now is I have a period of 2 pi. My intervals in this case, though, are a little bit different. Since my period is only 180 degrees and I'm talking about a 2-quadrant section that gets me to 180 degrees, to find my intervals for tangent and cotangent, all I need to do is divide by 2. So that's 2 pi over 2, or pi, for my intervals. So if I go here and here, I have a whole period of tangent. Now, we know once again that at normally 0 degrees, let's go around our unit circle, we have 1, 0, and I'm looking for a y over x value, so that's 0. I know my next interval is going to have an undefined value of tangent, so that's an asymptote. And then my next value will be back at 0. In between the first two intervals, I have that root 2 over 2 value and root 2 over 2, which gives me a tangent of 1. So my graph will look something similar to this. And that's one period of tangent. We'll graph the cotangent. Period in this case is equal to pi over k, or 3 in this case. And if I want my intervals, again, since it's cotangent, I take my period and divide by 2, which is like multiplying by 1/2, which gives me pi over 6. So again, I start at 0, I move over pi over 6, and 2 pi over 6 is pi over 3. So there's my interval. Now, again, I'm going to look at a circle, and at 0 degrees, I'm going to look at the x divided by the y value, which is undefined. Going to my first interval from there, or quadrant, I know I have a cotangent value of 0, and when I end up at this quadrant value, I have an undefined value for cotangent. Again, I have a 1 value in between my first two intervals, so I graph my cotangent value. Now we're going to switch it up a little bit. Rather than graphing, we're going to write the equation of a secant function. And we know that our secant function is a secant k theta plus c plus d, I think is what we use. So this says we have an amplitude of 3, so this can go right here. Secant, and we know that our period is 3 pi over 2. So 3 pi over 2 is equal to 2 pi over k. If I want to find k, I take 3 pi k, set that equal to 4 pi, thus k is equal to 4/3. So this is 4/3 theta, And we don't know what this C and D does yet, so we're just going to leave the problem like this. And then we're going to write the equation, spelled that wrong, the cotangent function with a period of 5 pi over 6. So in this case, no amplitude, but I know my period, which is equal to pi over k, is equal to 5 pi over 6. That's the period. Again, if I want to find k, I say 5 pi k is equal to 6 pi by doing the cross product. Therefore, k is equal to 6/5. And therefore, we can take and say, well, y is just equal to cotangent of 6/5 theta, and be done. And that's all we've got today. Do your My Math Lab, fill out the summary, and we'll talk about it tomorrow.